Hello all, welcome back to my channel Math Made Easy. In the previous videos I solved questions till question number 30. In this video we are going to start with question number 31. So here we need to prove that root 3 is an irrational number. In order to prove this root 3 an irrational number, we are going to follow method of contradiction. What is this method of contradiction? In this, we are going to assume that the given statement is wrong. So, given statement is wrong. This is our assumption. We assume that given statement is wrong. This is our assumption. Then, we are going to assume this statement and then we are going to proceed by using some known facts. Okay. Then at certain stage we are going to get a result which contradicts our assumption. Okay, so let us say this is the result. Now this result contradicts our assumption. So the result is contradicting our assumption, means our assumption is wrong. Our assumption is wrong means what is our assumption? We are taking that the statement is wrong. That means the given statement will be correct. So that's how we are going to prove this. Alright, now since in this method of contradiction we are going to assume that the given statement is wrong, that means so here the given statement is root 3 is an irrational number. So it is not an irrational number means we have to assume that root 3 is a rational number. So let assume that root 3 is a rational number. So if we assume root 3 as a rational number, we know that any rational number can be expressed in the form of p by q, where p and q are integers and q not equal to 0. Where p and q are integers and q not equal to 0. So moreover, we are going to assume that this p and q have no common factors. That means they are co-primes. Okay. P and Q are co-primes. That means they should not have any common factors for both P and Q. Alright, this point is important. Okay, now cross multiply, we get P is equal to root 3 times Q. Now square on both sides, we get P square is equal to 3Q square. Right? Now, P square is equal to 3Q square means what does it mean? 3 is a factor of p square, or p square is divisible by 3, right? So, if you have any confusion here, let us say we can write 12 is equal to 3 into 4, right? So, 3 is a factor of 12 and 4 is also a factor of 12. So, if we write some number, let us say we are writing some y is equal to 3 into some x, right? So, this 3 is a factor of y. That means y is divisible by 3. Factor means that that particular number divides this number completely, right? So in this case, p square is equal to 3q square means p square is divisible by 3. 3 is a factor of p square, right? It implies p square is divisible by 3. If p square is divisible by 3, it implies p is divisible by 3. Alright, so let us say this is a result 1. Since p is divisible by 3, we can write p as 3 into some constant, right? So some a, where a is any integer, So p square is equal to, if we square on both sides, we will get 9a square. But from this, we have p square is equal to 3q square. If you substitute that, we get 3q square is equal to 9a square. So we can cancel 3. We have q square is equal to 3a square. Again, q square is equal to 3a square means 3 is a factor of q square, or q square is divisible by 3. If q square is divisible by 3, q is also divisible by 3. Q square is divisible by 3. If q square is divisible by 3, it implies q is divisible by 3. This is our result 2. So if you look at 1 and 2, P is divisible by 3 and Q is divisible by 3. That means from 1 and 2, P and Q are divisible by 3. But what is our assumption? P and Q are co-primes. If they are co-prime, they should not have any common factor, right? P and Q are divisible by 3 means 3 is a common factor for both P and Q, right? Which contradicts our assumption, right? Which contradicts our assumption that P and Q are co-primes. So why this contradiction has arisen? Because of a wrong assumption. What was our assumption? Root 3 is a rational number. That means since our assumption is wrong, the given statement is correct. Therefore, root 3 is an irrational number. That's how we can prove this. Hope this is clear. So with this, we have completed section C. We are going to start with section D in the next video. Thank you.